All right, hi guys, we're gonna do chapter 1 review. We're just doing the first half, which is due today, and then we'll do the second half for tomorrow. Start on page 62. Number 1, it says graph each point on a number line. So first thing we have to do is draw our number line. And looking at it, I can see A is at 4 and B is going to be at -2. So there's no real right or wrong way to draw out your number line, just as long as you have up to +4 and down to -2. And then you can just put the point here and here on 4, -2. 4 is labeled A and -2 is labeled B. Number 2, state the opposite of each number. So for A, we've got 15. The opposite of +15 is -15. And for B, we've got -7. The opposite of -7 is +7. Number 3, order the integers from least to greatest using the less than symbol. So in the book, we've got a 9, a -8, and a -9. So we're just going to start with the smallest one since we're going from least to greatest, which is -9. But instead of putting the commas in the way that they originally listed them, we're going to use the less than symbol. Like -9 is less than -8, which is less than 9. Number 4, same idea, but this time we might have to think a little bit. They added some absolute values and things in here. So number 4, we've got -15, the absolute value of -21, a 0, and the opposite of the absolute value of -11. So I might actually just write some extra things underneath just for the purpose of deciding which one is actually the least and which one is actually the greatest. But then your answer should have these original numbers that are written in the book, written in this way in your answer. So this would be like my side work here. So -15, the absolute value of -21 is +21. Then we've got our 0. And then we have the opposite of the absolute value of -11, which is going to be -11. So these I'm just doing for my side work, but my answer should have the original numbers, which means my least is -15. Next one would be the -11, which was originally written as the opposite of the absolute value of -11. Oh man, I just realized here I wasn't writing the less than symbol. I was writing the commas. Okay, so we have -15, which is less than the opposite of the absolute value of -11, which is less than 0, which is less than the absolute value of -21. And that would be your final answer. Okay, number 5. Evaluate each expression. So they want to know what is the absolute value of -62. This is +62. Number 6, what is the opposite of the absolute value of 5 minus 3? So we're going to go to the inside first since we always do the grouping, inside the grouping first. I'm going to keep the negative out front. For now, I'm going to keep the grouping symbol, and I'm just going to do 5 minus 3, which is 2. Absolute value of 2 is 2, but we still have this opposite in front, which needs to stay in our answer. Number 7, use a number line to evaluate the sum 4 plus -7. All right, so we're basically just going to be drawing out what it would look like if you were to do this on the number line. I can see I'm going to start at 4, but then I'm going to be going left 7 because it's a -7. So I just need to make sure on my number line, I think it would make sense if we do -4 to 4. And again, there's really no right or wrong answer in drawing and how many numbers you put on your number line, as long as you can answer and show the question and represent the question being asked. So you're going to start at 4, and then you're going to go -7. So 1, 2, 3, 4, 5, 6, 7 is where you end up. Oh boy, that was fancy on this tablet here. Then you end up here. So this is our answer, -3. Number 8. Define subtraction using words and then using symbols. So subtraction is adding the opposite. There's your words, and your symbols is when they want you to throw in the A's and the B's or the X's and the Y's, or really whatever symbols you would like. I'm going to stick with A and B. So I'm going to show that, let's say I'm subtracting A minus B, but I'm going to show that it's the same thing as adding the opposite. So I'm still going to have the A, but instead of a minus, I'm going to add the opposite of B, which is -B. Number 9, evaluate each expression. -19 plus 12. Remember how we talked about when you're evaluating expressions, you should not put equal signs and things like that. So this is no. You should be doing things down in columns. So -9 plus 12, I'm sorry, -19 plus 12, we've got 2 different numbers with different signs. So what that means, different signs, we subtract 19 and 12, we get 7, and then we're going to keep the sign of the bigger number, which in this case is 19. Number 10, 9 minus 15. So this is a case that we're going to apply what we used in number 8, our definition in number 8, which subtraction is adding the opposite. So you could either go ahead and mark it. I wonder if I can get a different color on here. I'll figure that out a different day. You can either mark it as plus the opposite, or you can go ahead and write it in the column underneath that this is the same thing. So 9 minus 15 is the same as 9 plus -15, which means now you're adding 2 integers that have opposite signs, which means you are going to end up subtracting them, and then you're going to keep the bigger sign. So in this case, it's -6. Number 11, -7 minus 2. Here again, we've got subtraction. So you can go ahead and add the opposite, rewrite if it helps. That means we are adding 2 integers that have the same sign, so you're going to add the numbers and you're going to keep the sign. Number 12, 29 minus -8 minus 17. So I'm going to go through here and get rid of all the subtraction. I'm going to add the opposite on each one. That means I keep the 29. I'm going to now add the opposite of -8, which is +8. And then instead of a -17, I'm going to add a -17. So what I really have is 29 plus 8 plus -17. So 29 plus 8 is going to be 37 plus -17. Now I'm adding 2 integers that have opposite signs, so I'm going to subtract them and get 20, keep the bigger sign, which is 37 on the 37, so it's a +20. Number 13, -8 plus 4 plus -7 plus 6. Well, this is convenient. I don't have to do any adding the opposites. I've got addition all the way across the board here. So I'm just going to go left to right. -8 plus 4. So I'm just focusing on this for the moment. Different signs means I actually subtract the integers and get 4. It's going to stay negative because the 8 was larger. I still have plus -7 plus 6. So now I'm going to move on to the next 2. Again, I'm just going from left to right. We should always be adding expressions, subtracting expressions. We always move left to right. So -4 plus -7, add them, get 11, keep the sign because they are the same. plus 6. Now I've got opposite signs, so I'm going to subtract and get 5, keep the sign of the bigger one. Number 14. 14 times negative 6. So right here, you're going to remember, now we're moving into multiplication rules. You've got two integers with different signs, or an odd number of negative signs if you want to keep it, think about it that way, which means you're going to have a negative answer. And then 14 times 6 is 84. Number 15. Negative 72 divided by negative 4. All right, so in this case, we've got 72 divided by 4, which is 18. And then both signs are negative, which means you've got an even number of negatives, so the answer is positive, 18. If you have a calculator, I don't mind if you're doing some calculator work here with the 72 and the 4. If you don't, I would just be over here on the side. I wouldn't waste time trying to think about it. I would just do some side work over here, do some long division quick, and you'll figure out pretty quickly it's 18. Number 16. 125 divided by negative 5. Same thing here. I don't mind if you do 125 divided by 5 on a calculator. No problem at all. If you don't have a calculator handy, don't waste time staring at it. Just do some side work. You'll get done quicker if you just do a little long division on the side than if you just try to rack your brain and whatever. Just go ahead and do the work on the side. All right, so 125 divided by 5 is 25. We've got one negative number, which means it's an odd number of negatives. So our answer is negative 25. Number 17, we've got a negative 7 times 2 times 6. Okay, I'm just going to be moving left to right on here since I'm doing straight multiplication all the way across. So negative 7 times positive 2 is going to be 14. Keep it negative because it's an odd amount of negatives if I'm just doing these two here. 14 times 6 is 84. And then keep your negative. It's an odd number of negatives again. Here's another one. 14 times 6. You might not know that off the top of your head. Don't worry. Just write it down real fast. A little side work. Number 18. 9 times negative 12 divided by negative 6. Okay. So I'm going to do the 9 times the negative 12. So 12 times 9, 18, 108. It's going to stay negative. Since I've got a positive 9, negative 12, it gives me a negative result over negative 6. So you could go over on the side here and do your long division or type it on the calculator. I'm going to get 18. In this case, it's a positive 18 because I've got a negative 108 and negative 6. Even number of negatives always gives me a positive answer. Okay, moving on. Number 19. So just a review of identify the property illustrated by each statement. In number 19, we've got the quantity x minus 2 times 0 equals 0. This is going to be the 0 property of multiplication. Anything multiplied by 0, your answer is going to be 0. 0 property of multiplication. Number 20, x plus 3 equals 3 plus x. This one is the commutative property of addition. The commutative property states that you can switch up the order or the starting point, and then you'll still be able to get the answer same answer when you're adding. Number 21, the product of 7 and negative 3 is also an integer. So 7 is an integer, negative 3 is an integer, and the product is also an integer. This is the idea of closure. And since we have the word product, that's the answer to a multiplication problem. So this is the closure of integers under multiplication, which is F. Number 22. The quantity 2 plus 5 plus 9 equals 2 plus the quantity 5 plus 9. That's kind of tricky to see how I was writing here. I might just try to back up and save myself some more space. Let's get it all on one line. So number 22, let me rewrite. Okay, if you notice, you've still got the same order. Here's your equal sign, right? You've got a 2, a 5, and a 9. On the right side, you've got a 2, a 5, and a 9. So the order did not change. You can't use commutative property here. Commutative property, the order changes. In this case, it's the parentheses or the grouping that's changing, or your association, your associations here. So this is the associative property. And because we have addition, it's the associative property of addition, which means this is C. Number 23, 8 times 1 equals 8. So I know it's going to be multiplication, one of those properties, and it's got a 1 in there. When you multiply by 1, you get the same thing back. We talked about a mirror happening here in class, which would be the identity property, like when you look in the mirror and you see yourself, your identity. So this is the multiplicative identity property. Number 24, 53 plus negative 53 equals 0. So these are when two opposite things end up being 0. This is the additive inverse property. You're adding two opposite things and the result is 0. They're additive inverses. Okay, great job, guys. So that was it for the first part of our chapter review, and we will continue on tomorrow with the rest.